Hi, welcome back to Introductory Algebra, section 4.8, dividing by a polynomial. Now, this can be really pretty messy, so hang in there and do a lot of problems to practice. So I have a couple of things I want to look at before we jump into actually dividing by polynomials. And so I have a couple of things on this board that we're going to look at. On the next board, we'll start getting examples, and as you'll see, these can be very big and very messy. And messy is really the best word that I have to describe them. All right, so what do I need to show you before we can start? The first thing I need to show you is this idea that we have of a missing, or sometimes it's called a skipped term. So an example of this is here. I have 5x cubed minus 4x plus 1. And so what I notice is that I have x to the third power, and then I have x to the first power, but I am missing x to the second power, right? In between 3 and 1 should be x to the second. So I'm going to put it into the polynomial. Y is going to be a placeholder for us, okay? And it's going to make our lives a lot easier and a lot more right when we try and do this long division if we put in that placeholder. So we don't have any x squared, that's why we're using a 0, but we need it there to make this actually work. So that's the first thing we need here on this board, missing terms. The second thing that I have for you is just a real straightforward review of long division. No x's, no polynomials, just numbers. So you can see on the board, I am doing the problem 7 into 485. I've already worked it out, but I just want to kind of remind you of how this goes. We don't try and do the whole division at once. Instead, we do 7, we can't do 7 into 4, so we do 7 into 48, right? We can do that, it goes in 6 times. So the 6 goes up front. So our first step there was to divide. 48 divided by 7. Second step then is to take 6 times 7 to get this 42. So our second step is going to be to multiply. Then we subtract. 48 minus 42 gives me 6. And then we drop down the 5 that was still there. And then we do it all over again, right? We repeat the process. So 7 goes into 65 now, 9 times. 9 times 7 is 63. Subtracting, you get 2. Now we don't have anything left to bring down, so at this point you have a couple of options. You could, this is our remainder, right? That makes the 2 the remainder. We could add a decimal point and bring down zeros, but we're really not going to want to do that when we get into polynomials, so that's not how we're going to treat it here. We could put a little r up top and say remainder 2, or you can write your remainder as a fraction, 2 in this case, over the divisor 7. So we get an answer of 69 and 2/7. And that's how we're going to do it with our polynomials. We're going to write our remainders as fractions. So I want to look at 2 examples dividing polynomials. The first one's not even going to have a remainder. Its remainder will be 0. And the second one will, and we'll go through both examples. But here's the thing. It's going to take this whole board to do just one of those problems. So we're going to have to do this a couple of times. So buckle up. This is going to be fun. All right, for my first example, I would like to do this problem, 4x squared plus 4x minus 3, all divided by 2x minus 1. So if you watched the video from section 4.7 on dividing by a monomial, here we can see the difference. In that last section, we just had one piece on the bottom. Here I have a binomial, and it could even be more. It could be a trinomial or 8 pieces for all we know. You won't see that here in this section of this book, but it could happen. And so we're going to set it up just like the long division problem that I did on the last board, the nice, regular, numbers-only long division problem. So importantly, the polynomial on the top goes inside the box. Polynomial on the bottom goes outside the box. And now we really are going to do the exact same process that we did on the last board with just the numbers. I'm going to take the first thing on the inside, in this case the 4x squared, and I'm going to divide it by the 2x. The first thing on the inside divided by the first thing on the outside. And now one big suggestion I have for you is to divide your paper and put your scratch work off to the side. These are messy enough without trying to do all the scratch work in the middle of the problem. Take it off to the side. So since I'm doing 4x squared divided by 2x, I take it over here, I write it down. 4 divided by 2 is 2. Subtract the exponents, 2 minus 1 is 1, and I get 2x. I put it up top. I like to line it up with the term that has the same power. because then when I get to the end, I know I'm done. But let's keep going. So now that I have the 2x on top, I have to take it and multiply by the entire divisor, by the 2x minus 1. So you can see I did that here. I took the 2x times 2x minus 1. 2 times 2 is 4. X and x make x squared, so I get 4x squared. 2x times the negative 1 is a negative 2x. And I bring it back and I write it down underneath, lining up those terms. Now, this is super important. Be really, really careful on this step. We are subtracting here, which means we're subtracting both of those parts. And this is a really common place where people get mixed up. Basically, 4 minus 4 is 0. Nobody has any problem with that one. But if you're not careful, this really looks like 4 minus 2. And I get that, right? I see a plus 4, I see a minus 2. It looks like it should be 4 minus 2, which is 2. But remember, we are subtracting this whole thing. So what I like to do is change it to addition and then just change both the signs on the inside. Then I still have 4 and negative 4, which makes 0, but now I can see that I actually have 4 plus 2, which is 6. So I get 6x, I bring down that negative 3. Then we do it again. Now I'm going to take the 6x and divide it again by the 2x. I did that right here. 6 divided by 2 is 3. 1 minus 1 leaves me without any x's, so I put the plus 3 up at the top. Then I multiply. 3 times the divisor, 2x minus 1. 3 times 2 is 6, so we get 6x. 3 times minus 1 is a minus 3. I bring that back over. Now I'm subtracting again. Again, be careful. I find it best and easiest to change it to addition and then change both signs on the inside. Doing that, 6 and negative 6 is 0. I don't have any x's left. And in this case, negative 3 and 3 makes 0. And since there's nothing left to drop down, my remainder is 0. This division came out nice and even. And my answer then is the 2x plus 3. All right, so I have one more example I want to do. It'll be big fun. And let's get to it. Okay, for our last example, I want to do this one. X cubed plus 3x minus 1, all divided by x minus 3. Now, on this one, we have a missing term. So I notice I have x cubed, then I have 3x. I don't have x squared. Okay, so I'm going to have to fill that in. We talked about that earlier. We're just going to put it in with a 0. And so when I come over here and write the problem, my x minus 3, the bottom goes on the outside. And here you can see I have x cubed and I put in a 0x squared. It's going to be a placeholder and we'll see why it's important here in just a second. All right, so plus 3x minus 1. So I do my division, right? I take the first thing on the inside, that x cubed, and divide it by the first thing on the outside. Again, I've got my board split so I can do my scratch work off to the side. X cubed divided by x is x squared, and I put that up top. Next we multiply. X squared times the x minus 3. X squared times x is x cubed. X squared times minus 3 is a minus 3x squared. That goes here. And now we're subtracting again. So again, be really, really careful. I really recommend change it to addition and change the signs on the inside. 1 and negative 1 make 0, so those x cubes are gone. That's good. We want that to happen every time. 0 and 3 makes 3, so now I have 3x squared, and I bring down the 3x and the minus 1. Then we repeat. I'm going to take my 3x squared and divide it by x. So you can see I did that here. 3x squared over x, 2 minus 1 gives me just 1x, so I get plus 3x, and it goes up top. Then I multiply. 3x times x minus 3. 3x times x is 3x squared. 3x times minus 3 is a minus 9x. And here we have it again, ready to be subtracted. Okay. Again, I'm going to change this to addition. I'm going to change the signs on the inside because that's useful. 3 and negative 3 make 0, so I don't have any x squareds left. 3 and 9 make 12x. Down comes the 1. I can keep going as long as I can do the division and it comes out nice. I'm going to keep going. So now I take the 12x and divide it by x. 12x divided by x is just 12. 12 goes up top. I multiply by the x minus 3. 12 times x is 12x. 12 times minus 3 is a minus 36. And I subtract one more time. This time I change the signs again, but I'm left with 35. Now there aren't any x's left, right? I can't do 35 divided by x. It's not going to work out. So now that makes the 35 my remainder. So just like we talked about earlier with the number problem that we did, I'm going to put it up as a fraction. So you'll notice I have a plus sign because we do have letters and it's kind of messy. But plus 35 over just x minus 3. And there you go. That's polynomial long division. It's a mess. So be careful. Be really, really, really careful. And definitely, especially if you're doing one of my tests, show your work so I can see what you're doing, because I'm really good at sorting through things and figuring out, hey, do they know what's going on? Did they make some teeny little mistake? And now I can go ahead and give a lot of partial credit. So anyway, that's polynomial long division. Have a wonderful day.